Hi everyone, my name is Pradyumn Kejriwal and today we'll discuss the 25th problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. So here I have my sheet and I'll open this problem. So okay, it is called basketball exercise. Finally, a basketball court has been opened in SIS, so DEMIT has decided to hold a basketball exercise session. 2 into N students have come into DEMIT's exercise session and he lined them up into 2 rows of the same size. There are exactly N people in each row. Students are numbered from 1 to N in each row in order from left to right. Now DEMIT wants to choose a team to play basketball. He will choose players from left to right and the index of each chosen player, excluding the first one taken, will be strictly greater than the index of the previously chosen player. To avoid giving preference to one of the rows, DEMIT chooses in such a way so that no consecutive chosen students belong to the same row. The first student can be chosen among all 2N students and a team can consist of any number of students. DEMIT thinks that in order to compose a perfect team, he should choose students in such a way that the total height of all chosen students is maximum possible. Help DEMIT to find the maximum possible total height of players in a team he can choose. Okay, so what they are saying is that we have total 2N players, 2N basketball players. Okay, so 2N basketball players who are arranged in 2 rows. So each row has N players each. Let's say first row and second row. Okay, and each player has a height HI. So H1, H2, H3 and so on. Like basically A1, A2, A3 and B1, B2, B3, right? And what we can do is we have to choose some players to make a team, right? But the thing is that what we can do is like, let's say we chose this one, then the next person we have to choose after this only. Like we cannot choose at same index, right? So only after this. So let's say after this we choose this person. So now we cannot choose second one also. Now we have to go ahead, right? That's the rules. So the first person we can choose anyone, but after that we have to go ahead. That is one rule, right? But another rule is that let's say we chose the first person from the row A. So now the second person has to be chosen from row B. Like if you are choosing second person, then it has to be from row B. You cannot choose 2 consecutive persons from row A. Okay. So this is not allowed. That okay, and also this is also not allowed because the 2 consecutive persons that you chose are from row A. Like because you did not choose anything from here, right? So you could choose like this, and this is fine. Okay. So these 2 are the rules, and you have to do what? You have to maximize total height. That is the sum of all heights, right? That you have chosen in the team. Okay, so that's the problem. And like you can see the samples. So in this sample we have 93573 as the first row and 58145 as second row. And what they are saying is that we can choose it like this. Like we can choose 9 from here, 8 from here, 5, 4 and 3, and it will give us the sum of 29, right? Then in the second example they show us like 1, 2, 9 and 10, 1, 1. So here they are not choosing from this index. Like if we choose like this, that the first index we choose 10, second one we don't choose anything, and third one we choose 9. So in that case we'll get the sum as 19, and that's the maximum possible. So like you can see easily that if you choose something from the middle row, then you won't be able to choose either 10 or 9, right? So this is the optimal way. Okay, so yeah, you can try to pause the video now, but yeah, before that I'll just tell you about the constraints. And the constraints are that n is up to 10 to the power 5, right? So since we know that in one test case we can perform approximately 10 to the power 8 operations per second, that's why since n is given to be 10 to the power 5, we cannot do O of n square solutions. Okay, what we can do is O of n or O of n log n. Okay, So yeah, now you can pause the video and try the problem by yourself, and if you unpause the video, you will see the solution. Okay, so at this point I'm assuming that you want a solution, so let's begin. So alright, let's take a sample test case and I'll explain using that. So let's see, let's say here we have 93573 93573 and 58145. Okay, so here what they're saying is that we can choose it like this: 9, 8, 5, 4 and 3, right? So ideally what we would do, like let's say that constraint was not there, that we had to choose alternatively. Like what if we could choose both, like two consecutive elements from the same row? In that case we will just choose the bigger one, right? Like here 9 is bigger out of 9 and 5, 8 is bigger out of 8 and 3, then 5, then we'll choose 7 and then we'll choose 5. So we would have chosen like this if we were allowed to do so, right? But the thing is that we cannot do this. It is not allowed because we have to choose, we cannot choose these two consecutively, right? Okay, so basically at each index I, let's say at this index I, we have three options, right? First option is either take from A, or we can do either take from B. A and B means the first and second row, right? Or the third option is that we don't take anything. Don't take anything. Right. And we want to maximize the sum of the players that we take. So this kind of seems like a take not take DP, right? Some knapsack DP types. Like we have three options at each index. And also we have some more constraints that we cannot choose two persons from the same row consecutively. Right. So let us try to formulate some kind of DP here. Okay. So okay, let's say I tell you that at the last index we have three options, right? Like at every index we have three options. So let us see the last index. Alright. I am trying to just formulate, like just give you the intuition for the DP here. So let's say we have this last index, right? So here either we can take this 3, or we can take this 5, or we can take none of them, right? So if we take this 3, then of course the problem boils down to finding the answer for this one, right? Like let's say I have chosen that I want to take this 3, then what is the maximum answer? Then what we can do is we can recursively find out the answer for these first 4 indices, right? And then just include 3 in that. But the problem with that is that what if in the optimal answer to this we had chosen the last element as this 7 or maybe this 5. Like let's say we chose this 5 and then we did not choose anything from this, and that's the optimal answer. Like of course that is not optimal, I mean, but hypothetically just think about that. Or let's say we chose this 7 at the end. Like when we were finding out the optimal answer for this this range, then that optimal answer contains 7 at the end as we chosen. Okay, so in that case we cannot really append 3 to it, right? So we need that information as well, that from which row did we take the last element. Okay, so we will maintain that information as a state of the DP. Okay, so it's like if we want to find out that what is the answer if I am taking this index, like if I want to find out that what is the answer if I want to take this, then if I know that what is the answer to this range if I can take the last index as only the second one. See, what I'm saying is, if I know that what is the answer for index up to I minus 1, okay, such that the last chosen player was from B. Like, let's say that I know that what is the answer for up to I minus 1, that is up till here, if we can only take the last person from second row. So if we know the answer to this fact, then we can just append this 3 to at the end, and then we can do it, right? So our DP state is clearly, like, I'll define my DP1 of I as the answer for prefix I, answer for the prefix I, if the last chosen index, the last chosen was from row 1 or was from A, right? And similarly, DP2 of I, I'll define as the answer for prefix I if the last chosen element was from B. Okay, so same definition but from B. So let's say we want to calculate the DP1 and DP2 of I. DP1 of I and DP2 of I. So let's calculate DP1 first. Alright. So let us say we have this array. Like, I mean, these two arrays, and this is the index I, for which we want to calculate the answer, right? So DP1 of I want to calculate for this I. What is DP1? DP1 is the maximum answer if we can choose, like, if we have chosen the last element from the above row, right? So there are like two possibilities, right? One possibility is that I have chosen this element and that's why it is at the end, like, that's why it is the last element and it is from row 1, right? So one possibility is I have chosen this is the one possibility, and another possibility is that I did not choose any of these and my last chosen element was somewhere here or here. Okay, so these two are the possibilities. That first possibility is that I chose AI. AI means the ith element at the A array, and second possibility is I didn't choose anything. I did not choose anything at the ith index. Okay, so we can just find out the answer for both of these cases and take the maximum, right? So if we have to take this index, then what does it mean? Then basically we have to ensure that from this part we are taking the last element from the B part. That means DP2, right? So we will use the answer of DP2 for this index I minus 1, right? So if we have chosen this, that means what is the answer? The answer is DP2 of I minus 1, and also we have chosen this, so we'll add AI, right? So this is one of the possibilities. Okay, and one more option we have, that we do not take any index from this one, like we do not take any player at this index. So that means since we are calculating DP1 of I, the last element must have been chosen from the first array. So it will be the same as DP1 of I minus 1, because we want to ensure that the last element was from the first row. So we'll use DP1 of I minus 1, right? So another option is DP1 of I minus 1. Okay, so we'll take the maximum of these two, and this expression is your basically DP1 of I, right? And similarly your DP2 of I will be the maximum of DP1 of I minus 1, because plus BI, like if we are choosing BI, then we have to ensure that the last element that we took was from the first array, or if we are not choosing anything, then we have to ensure that it is from the second array. So max of DP1 of I minus 1 plus BI comma dp2 of I minus 1. So this is our transitions. And finally, what is the answer? The answer is, of course, the answer for the entire array, right? So I is equal to n minus 1. Like, we'll choose the entire array and we'll take the bigger one, like whatever is the maximum from dp1 of n minus 1 and dp2 of n minus 1. That will be our answer. Max of dp1 of n minus 1 comma dp2 of n minus 1, right? And the base case is pretty simple. Like, dp1 of 0, what is dp1 of 0? It is the answer for the first index, just the first index. So that's, of course, ai. Like, dp1 means you have to choose the first row, right? So it is ai. And dp2 of 0 is equal to bi. I mean, sorry, not ai, a0, right? a0 and b0. So this is the base case and this is the transition. And finally, this is the answer. The max of dp1 of n minus 1 comma dp2 of n minus 1. Alright. So that's the entire logic here. And I'll just show the code now. So in the code I have this main function, the fast IO, and solve function. And in solve function I have int n cnn. I'll take the input of both a and b arrays. And then I have dp1 and dp2. I am doing it in long because it can overflow, right? So dp1 of 0 equal to a of 0 and dp2 of 0 equal to b of 0, the base cases. And then we'll iterate from I equal to 1 to n minus 1. So dp1 of I equals to max of dp1 of I minus 1 comma dp2 of I minus 1 plus a of I. And similarly, dp2 of I equal to max of dp2 of I minus 1 comma dp1 of I minus 1 plus b of I. So this is what I just wrote here, the transitions. And finally, I'll just say out the max of dp1 of n minus 1 comma dp2 of n minus 1. So the code is just pretty much the same as what I wrote here, right? Just be careful about using long because it might overflow. So the time complexity of this is just O of n, because this is O of n loop, and the space complexity is O of n because we are storing these dp values. Actually, we could have done it in O of 1 space as well, because the dp1 of I just depends on the previous values of dp1 of I minus 1 and dp2 of I minus 1. So we can just store the last two values and not the entire array, right? But just to be clear about the code, I just did it like this. So this solution take O of n space, but you can do it in O of 1 space as well, right? So tc is O of n and space is O of n. So yeah, I hope you understood this, and thanks for watching.